Hi folks, and welcome back to Math with Captain Rod. The purpose of this video is to discuss the general requirements for integrals of this form to converge or diverge. Integral 1 over x to the p dx, where p is some value here. And what I just went through with my class was the following examples here. We looked at integral 1 to infinity of 1 over root x dx and found that this diverged, didn't yield an answer. We also looked at integral 1 to infinity of 1 over x squared dx, found that that converged, did get an answer. So again, the question here now is I want to talk about kind of in general here, what are the criterias of p, the power, for that integral to be divergent or convergent? And it's important to have a good handle on that because when you're studying lots of integrals of this form, of new integrals of complex form, I'll say, it's handy to have a set of them that you know about, a set of integrals that you know whether they converge or diverge. So we're going to just take a look at this and just try to basically compute this. Now this is an improper integral, so the first thing we probably would want to do is write this maybe limit as b goes to infinity of integral 1 to b, and I think this 1 over x to the p, why don't we write this x to the minus p dx, and this is going to equal limit as b goes to infinity of x to the 1 minus p evaluated from 1 to b divided by 1 minus p. So this is just the power rule. Add 1 to the power. That'd be minus p plus 1, which I'd prefer to write 1 minus p. Divide by your new power, which would be 1 minus p. All right. We're going to take a look at this. This is going to equal limit as b goes to infinity of b to the 1 minus p minus 1 to the 1 minus p, and that's all over 1 minus p. Now I'm going to go ahead and take this 1 minus p way out in front of everything because that's some constant for this problem, 1 over 1 minus p. Then we got limit as b goes to infinity of b to the 1 minus p minus 1 to the 1 minus p. As I look back here, this is a p here, not a b, a p. All right, so this part in red right here is no problem right there. Actually, let me back up and talk about this. 1 to the 1 minus p is 1 for all values of p. So the thing in red here is a 1. This, however, as b goes to infinity, whether or not this thing converges or diverges depends basically on whether or not b ends up upstairs or downstairs. I'm going to take a moment here, get rid of some of this, and kind of put this center stage here because it's really all about this term that I want to talk about. So I'm going to get rid of this. And again, this is the really important thing right here now. We're going to center stage this. So, and again, the big thing here, you got to remember, we're taking limit as b goes to infinity. This thing here can be thought of as a fraction. In order for this thing to converge, the b has to end up on the bottom. You know, for example, let me just say that, let's say p were a value of negative 1. Then this would read 1 minus a minus 1, which is 2. So this reads b squared. As b goes to infinity, b squared goes to infinity, and the integral diverges. Let's say p were negative 3. This would be b to the 1 minus a minus 3, which would be b to the 4th. b to the 4th, as b goes to infinity, b to the 4th also goes to infinity. Let's say, for the sake of example, that p were 2. This is now b to the 1 minus 2, which is 1 over b. As b goes to infinity, 1 over b goes to 0. and then this thing would converge. This will converge as long as P is greater than 1. Right? I did the example for 2. If I do the example for 3, this is going to read b to the 1 minus 3, which is b to the minus 2, which is 1 over b squared. As b goes to infinity, that would go to 0, and the integral would converge and so forth. So this thing will yield a value as long as p is greater than 1. If p is less than 1, the integral diverges. If p is greater than 1, the integral converges to a value, and we even can tell a value of what? For any value of p greater than 1, this term goes to 0. This is minus 1 times 1 over 1 minus p, which we can write 1 over p minus 1. So any integrals of this form, whether they converge or diverge, it's all about the value of p, what that power is. If that power is less than 1, 0, negative 1, negative 2, negative 3, the integral is divergent and there's no answer. If the p is greater than 1, the integral converges, and it converges to this value, 1 over p minus 1. I'm going to take a look at now as a separate case, what if p equals 1? So if p equals 1, we're looking at integral 1 to infinity of 1 over x to the first power dx, which we would then write like this, limit as b goes to infinity, integral 1 to b of 1 over x dx equals limit as b goes to infinity. Now the integral of 1 over x dx is natural log x. So this is going to be natural log of b minus natural log of 1. And when we take the limit as b goes to infinity, natural log of b goes to infinity, so the limit does not exist. Right? And again, integrals divergent. So any integrals of this form, it's all about p. If p is less than 1, the integral diverges. No point in working it. If p is equal to 1, the integral also diverges. If p is greater than 1, the integral converges, and we know to a value of 1 over 1 p minus 1. Now this is very handy to know because this tells us about a whole bunch of classifications of functions that converge or diverge. So I'm going to take a moment here and pause this and clean this up. Back from my little break here, what I've done here is I've cleaned some things up and I've written some examples here to discuss. We're going to take a look at integral 1 to infinity of 1 over x to the 4th dx, integral 1 to infinity of 1 over x to the 2/3 dx, and integral 1 to infinity of 1 over x to the minus 2/3 dx. So I'm going to go through and just kind of discuss these as it's related to my previous part of this video here. So here, integral 1 over x to the 4th dx, the p is 4. 4 is greater than 1, so the integral is convergent, and we know what it'll converge to. This thing is going to equal 1 over, whoops, and I can't remember if it was p minus 1 or, yeah, or 1 minus p, yeah, 1 over 4 minus 1, which is 1/3. This integral here, p is less than 1, so this integral diverges. And I'm going to ask my class here, so what do we think about this one? First of all, identify the value of p. So converge or diverge? Is p greater than 1 or less than 1? Less than 1. So diverge or converge? Diverged is correct. Okay. All right, so these are kind of examples of how we're going to use this. I think what I'll do is make another video talking about in what context. Right? So hope this video helps. Have a great day.